All right, we're going to be back on volume. So once again, volume is what's inside of a figure, and we're going to be doing two shapes here, the volume of a pyramid and the volume of a cone. Okay, a pyramid is just like pyramids. Okay, it goes from the top all the way up. That's what we call the height, and then you have a square base on the bottom. A cone, for example, has a circular area on the top and then a height going down here like this. So some real-world examples. Here we have another example of pyramid. We call this the apex, or the top, and there's the bottom as the base. Okay, the formula for both of these is the same. Okay, our volume equals 1/3 times the area of the whole base times the height up to the apex. So the first thing you do is you find your area of your base, you multiply it times your height, and then you divide by 3. Okay? A triangular pyramid, which shows up sometimes, all you do is you treat it exactly the same way. You find the area of the base times the height, or you could pretend that it's a rectangular pyramid and then divide the whole answer by 2 at the end. Okay? Cone, same way. Area of the base times the height. The only difference here is because it's a cone, this is a circle, so you got to find the radius, and then the area of that base is r squared times pi, because it's a circle. Okay, so here's a figure. So it looks like we have the front side is 80, all the way going back is 80, so that means the whole back is 80, and this side's also 80, and then the height's 100. So our formula is 1/3 the area of the base times the height. So the area of the base, because the base is a rectangle underneath it, is going to be 80 times 80, which should be 6,400. We then take that times the height, which in this case is 100, so it adds 2 zeros to it. So that's 640,000, or 640,000. We then take that number and we divide by 3. And that's getting a little bit tough for me to do in my head. We get 213,333 approximately. And since it's volume, we do meters cubed. So that's what we do. Area of the base, right here, times the height, divided by 3. Okay, for a cone, the area of the base is going to be a little different, but it's the same idea. So it's 1/3 area of the base times height. And remember, you're going to have to memorize this because the Common Core decided I can't give you formulas, so there's no notes here. So we're going to do the area of the base will be 18 squared times pi, since it's a circle. Well, 18 squared is something I cannot do mentally. Whoops, that's not the right button. 18 times 18, 324, times pi. Remember, you can make that a decimal if you want. Take that times our height, which is 1 foot, but the problem is that's feet, that's inches. So this has to convert to 12 inches. So I take 324 times 12. 3,888 times pi. And then because it's not a square shape, we have to divide by 3. (1,296 pi), or you could multiply out that pi. Inches squared. Now, if you wanted to make this smaller numbers, which is totally fine, you could have changed this radius into 1.5 feet, because it's 1.5 feet, and then kept that a 1, and that would have been fine. Nothing wrong with that. But your label would have been different, obviously. All right? Hardest part of these problems is remembering to divide by 3. Got to remember to divide by 3. Okay, like a rectangle, a cylinder, those types of things, you don't divide by 3. But for these, you have to. Try these two on your own. Okay, this one on the top is a little bit tricky. Since this is diameter, that means the radius is 4.5. So for this one, it's 4.5 squared times pi times our height of 10 all over 3. So that's 4.5 times 4.5 times 10 divided by, whoops, can't believe I did that. 67.5 pi, or 212-ish inches cubed. Bottom one, it's a little harder to see, but rectangular pyramid. So I have, I'll write it out here. My pen is kind of wrapped up. 80 times 60 times our height of 100 divided by 3. $160,000 feet cubed. Biggest thing with this one, formula. Gotta know the formula, which is volume equals 1/3 area of the base times the height. There's the book assignment, but there's also an IXL assignment posted online.